Hello everybody, this is Mrs. Braband and I am going to do a very quick couple examples in preparation for the Unit 2C Solving Inequalities quiz that's coming up soon. This example is going to go over, the quiz covers two examples. So if you look at this page, the quiz covers both inequalities by solving with graphing and also algebraic. So most of the ones we're going to be doing is polynomial, but there may be a few with the rational graphs being broken up. So the major topic is number one, but please be aware that I might give you a graph like a rational, and you may need to do that as well. So talking about that graph, I'm going to look at numbers 2 and 3 on this page here. 2 and 3. Both of these are obvious graphs. We've got the first one is a polynomial and the second one is a rational. So remember, there's no denominator here to worry about a break. But this one being rational has more than one thing that we have to worry about for breaks. So we're going to have to look at breaks and how they happen around the zeros, and then official jumps in the graph or breaks in the graph where we have a VASI or a hole. So that's what we need to do there. Okay, so for number 2, we are going to answer the question, find f of x when it is greater than or equal to 0. Let me write that a little bit bigger for you. We need to find out what interval that's going to happen at. So what we need to do is we need to look at the graph very closely and recognize that when y values are above 0, that means they're above the x-axis. So if this is your x-axis, which is where y equals 0, we're only concerned about what's above. So we're concerned about this, but since there's an equal bar, we also are concerned with that dot at -1. The rest of this graph, as I keep going, because I'm going to do little dots here, this I don't care about right now. I don't really care about all these little inflections going on here, because those are all below the y-axis, and I'm greater than right now. So I'm going to ignore all that. Finally grab this again at the point 3, because the equal bar says grab the intercept, and then look above the graph again. So the only parts I'm agreeing with here to answer this inequality is what's shaded. So that means I now need to read the interval, and I need to remember that I did grab those intercepts with an equal bar here, so I need to use brackets. So coming from the left, we went from -infinity all the way over to this dot at -1, and since that's on the intercept and we do want an equal bar, we grab it, we skip everything underneath, and we come back up and pick up the other intercept at 3 and bracket it off because we do want it, and then we go to the right further and further and further, and that's positive infinity. So there's your solution set for this polynomial at when the function is greater than or equal to 0. Let's go to the next one. This is a rational function, so there's just more things to look at. So find the x-axis first. That looks like it's a HASI. So that means there may or may not be intercepts. It looks like there is one here, so that's going to be something I'm very concerned about. Okay, and I'm also concerned about these VASIs at -4 and a VASI at +1. That's going to concern me when I look left to right. So this function says we want to look at f of x when it's less than 0, and then write the interval out. Less than 0 means underneath the x-axis, so I'm going to shade everything underneath, but not an equal bar, so I can't grab that intercept. So I'm actually going to get rid of it now because I just use it as a boundary, and then I have to look below it. If I go to the right again, oops, there's nothing underneath. So again, I'm not really caring about this part of the graph or this part of the graph right now, because those are the y values that are above the x-axis. That means they're above 0, and I don't want those. I want less than, which means below. So again, less than, below the x-axis, meaning all my negative values. The other question was greater than or equal to. That's above the x-axis, on the x-axis, meaning all the positives. Okay, so let's go back and finish this one here, please, the rational. All right. On the graph, it looks like I'm going from -infinity all the way over to that VASI, which is -4. Then I jump, and I don't really concern myself with that part, and I don't pick it back up again until I'm at the boundary of -1. I don't bracket it because there's no bar there, and then I keep going all the way over until the next VASI, which is at 1, and then I close that off. Those are two examples of solving inequalities graphically. Remember to look at the other video to find out how you solve it algebraically with a sign test. I hope that helps. Best of luck. Reach out if you have questions. Thank you.